This is for specialist maths that comes out of 6D, taking the second derivative of sec x on 3, which is 3k. So I'm going to take the first derivative first. So I'm going to put I'm going to say that y equals 1 on cos of x on 3, which means y equals cos of x on 3 to the negative 1. Which means y dash will equal negative 1 cos x on 3 to the negative 2. The derivative of the inside is sine x on 3 negative, and then times by 1/3, because the derivative of the inside of the sine is 1/3. So that leaves me with negative times negative gives positive, so sine of x on 3 over 3 cos of x on 3 squared. That's what y dash is. Now I'm going to do y double dash, but I'm going to use the quotient rule, where u equals the sine of x on 3, which means u dash equals cos of x on 3 times 1/3. And v, which is on the bottom, is 3 cos of x on 3 squared, and v dash will be 6 cos of x on 3 times negative sine of x on 3 times 1/3. So 3 goes in 6 twice, and it's going to be negative, and I've got the cos of x on 3 times the sine of x on 3. Okay, so looking at finding my second derivative based on this quotient rule, so I would be expecting y dash to equal v times u dash. So the 1/3 and the 3 cancel to leave cos of x on 3 cubed minus, so that becomes plus 2 cos of x on 3 sine of x on 3 squared, all on top of v squared. So 9 cos of x on 3 to the power 4. So what have I got? I can take out a common factor of x on 3. So if I take out cos of x on 3, I'm going to have cos of x on 3 squared plus 2 sine of x on 3 squared. And I'm going to put this all over 9 cos of x on 3, and then put cos of x on 3 cubed. So break this 4, and that will cancel with that. I then might put a 1/9 and take one of these coses, so 1 on cos of x on 3. And then I'm going to have cos of x squared on 3 over cos of x on 3 squared plus 2 sine of x on 3 squared over cos of x on 3 squared. So that gives me 1/9 sec x on 3 times 1 plus 2 sine on cos is tan x on 3 squared.